Assalamualaikum and good day to everyone. So today I'm going to present to you my video assignment for the subject EMM3103, which is static. So before we begin, let me introduce myself first. My name is Raja SYAFIQ HAMZAH and my MATRIC number is 206053. So let's begin with the presentation. So basically our first topic is the basic concept of statics. So before we begin, I would like to ask all of you guys what is static and static equilibrium means. Static means that a physical science that deals with the effects of forces on objects, that is either the object is at rest or move with constant velocity. Meanwhile, static equilibrium means that forces and moment in balance with no deformation. Next, we are going to talk about Newton's three laws of motion. We have the first law, second law, and the third law. So we begin with the first law. First law is state that a particle originally at rest or moving in a straight line with constant velocity tends to remain in this state provided the particle is not subjected to an unbalanced force. So right here we can see there is a diagram that explains the first law. Next, we are going to the second law. Second law states that a particle acts upon by an unbalanced force experiences an acceleration that has the same direction as the force and magnitude that is directly proportional to the force. If force is applied to a particle of mass, this law may be expressed mathematically as F equal to ma, which is the F is for the force, m is for the mass, and a is the acceleration. So right here we have the figure that explains the second law. Next, we are going to the third law, which is the last law of the Newton's law. So the third law states that the mutual forces of action and reaction between particles are equal, opposite, and collinear. So right here there is a figure that explains about this. There is a particle A and B which is in contact together, and the force of A on B is the same with the force of B on A, but it is in opposite direction. Newton's law of gravitational attraction states that F is equal to the G times with the m1 and m2 divided by the r square, which is the F is stand for the force of gravitational between two particles, and the G is the universal constant of gravitational, which is the value is 66.73 times 10 to the power of negative 12, and m1 and m2 is for the mass of each two particles. Meanwhile, r stands for the distance between two particles. Next, we are going to talk about weight. Weight is the only gravitational force considered in our study of mechanics. If we assume the Earth to be a rotating sphere of constant density and having a mass m2 is equal to me, then if r is the distance between Earth's center and the particles, we will have a new formula which is W is equal to G times with m times with the mass of Earth divided by the r square. Then we letting the G is equal to GME over r square. We substitute the G with the GME over r square. Then we will have a new formula that is we have fusion, which is the W is equal to M times with the G. Next, we are going to talk about force system. Force is an action of one body to another body, and force also is a vector quantity which have a magnitude and direction. Vector is characterized by certain character, which is the first character is a point of application. Point of application is a single point where the force is applied. So basically, if you see the diagram below, the A is what we call the point of application. Meanwhile, the second character is it must have a magnitude, which is a value. So the third character is it must have a line of action and direction. So which is a line of action is a line in space passing through point of application in same direction as force. So it can be a free, sliding and fixed. So basically we back to our diagram. You can see the force B. It is a line of action and the direction is to here. So this is what we call the line of action, which is the red arrow. Next, we are going to talk about dot product. Dot product is when we have a two vector, which is vector A and vector B. So it is a product of magnitude A and B and the cosine of the angle theta between A and B. The dot product often referred as scalar. It is not a vector because the result is scalar. So right here there is an example to make us more understand about the dot product. So right here we have two vector, which vector A, the blue one, and the vector B, the red one. So when we want to do the dot product, basically we just take the magnitude of the A times with the magnitude of the B times with the cos theta. In this case, the cos theta is the angle between the two vector. So right here is the theta. So if the magnitude of B is 1, then the formula will become only the magnitude of A will time with the cos theta, the angle between the two vectors. That's all for dot product. Next, we are going to talk about 3D vector. There is three ways to show the 3D vector, which is the first one is in the term of ijk, which is fx, fy, fz. And the second one is by using the directional cosine. And the third one is by using the coordinate. Next, we are going to talk about the force system and type of the force. So basically, force system have two type of force, which is the first one is the coplanar force, and the second one is the non-coplanar force. For the coplanar force, it's a line of action for all forces that are lying on the same plane. Meanwhile, non-coplanar force is a line of action for all the forces are lying on the different plane. So for coplanar force, it have four types, which is the first one is collinear, and the second one is concurrent, and the third one is parallel, and the last one is general. Meanwhile, for non-coplanar, we only have three, which is concurrent, parallel, and general. Next, forces are characterized by two types, which is the first type is the external forces, and the second type is the internal forces. So we are going to move through the external forces first. External forces on a rigid body are due to the causes that are external to the body. They can cause the body to move or remain at rest as a whole. For example, force of gravity applies external force on the object. For the second type of the force, which is the internal force can develop in any body, not just in a rigid body only, that keep all the particles of a body together. For example of internal force, we have an internal tension or compression in a bar, bending moment in a beam, and the others. Next, we are going to move to the procedure for analysis of forces. We have two types of procedure, which is the first one is by using the parallelogram law, and the second one is by using the trigonometry. First one, we are going to talk about the parallelogram law. The first one is we need to make a sketch using the parallelogram law. And then the second one, if two component forces add to form the resultant force. And the third one is the resultant force is shown by the diagonal, the parallelogram. And the fourth one, the step 4 is the component is shown by the side of the parallelogram. And the 5, which is the last step, is to resolve a force into component along two axes directed from the tail of the forces. We must start at the head by constructing lines parallel to the axis. Next, label all the unknown and unknown forces, magnitude and angles. And the third one is identify the two unknown components. So next we are going to the trigonometry method. It is only have three steps, which is the first step is redraw half portion of the parallelogram, which is this one we must make it become triangle. That's why we must redraw it half portion only. The second step is the magnitude of the resultant force can be determined by the law of cosine. Meanwhile, the law of sine, we can determine the two things, which is the first one is magnitude and the second one is direction. These two things we can determine it by using the law of sine. So for the diagram below, we can see this is the law for the sine and this is the formula for the cosine law. Next, we are going to move to the example. The screw ice is subjected to two forces, F1 and F2. Determine the magnitude and the direction of the resultant force. So basically, this is the diagram. So when we got this, we are going to solve it using. Next, we are going to solve this is the answer for the example. So basically we are using the trigonometry method. So if we said we are going to use the trigonometry method, we must make a triangle first, because law of cosine or law of sine is only applicable if the object is in triangle. So we make it become triangle first, so we will get this diagram. Then we'll use the law of cosine to get the magnitude of this blue arrow, which is the resultant force. We just sub it into the formula, then we will get the resultant force is 213 Newton. Then we are going to calculate the angle. So to calculate this angle, we are using the law of sine. So we just substitute it in the formula like usual. Then we will get the angle is 39.8. Oh, I think this one is some mistake. It is only angle theta. It's not sine theta. So next we have got the angle, which is 39.8 degree. Then we will calculate the theta. The theta is calculated from the is measured from the horizontal, which is we must include this 15 degree. So we just add it with the previous answer we got by using the law of sine, which is 39.8 plus 15. Then we will get 54.8 degree. So that is the angle for the resultant force. So that's the answer for this example. Next, we are going to talk about equilibriums. When all the forces that act upon an object are balanced, then the object is said to be in the state of equilibrium. The forces are considered to be balanced if the rightward forces are balanced with the leftward forces, and the upward forces is balanced with the downward forces. This, however, does not necessarily means that all the forces are equal to each other. So right here we can see in this diagram, it is the two objects are at equilibrium since the forces are balanced. However, all the force that act upon this object is not equal. Not all of them are 50. there is the force upward is 50, meanwhile the force in the rightward is the 75. So that is why I say that we can assume that if the object is in equilibrium, we can assume that it have the same forces for each other. Next, balance is the key word that is used to describe equilibrium situation. Thus, the net force is zero and the acceleration is zero. Object at equilibrium must have an acceleration of 0 mx squared due to the Newton first law of motion. An acceleration of 0 ms squared does not mean the object is at rest. An object at equilibrium is either 2. It is the object we said that in equilibrium there's only 2. For the first one, when the object is at rest, and the second one when it is in motion and continuing in motion with the same speed and direction. If the object is related with one of these two conditions, then it is said to be equilibrium. It can be said to be in equilibrium. Next, we are going to talk about free body diagram and a procedure to draw it. Basically, a free body diagram is a drawing that shows the particles with all the forces that act on it. So right here I have 3 easy steps of procedure to draw free body diagram, which is the first step is draw the outline of the shape. But if we don't want to draw the outline of the shape also can, we just put a big dot where the center of the force act on it. Next, the second step is show all forces that act on it, and the last step is identify each force. So right here I have one example, which is this picture. We can say that like this is a ring that attached to a two string, which is the A string and the B string. So from this picture or diagram, we can transfer it to free body diagram. And with our free body diagram will look like this, that have one force there on this side, one force on this side, and another force that is going downward. This force is called TA, which is the tension of A, and this force is called TB, which is the tension of B. The force that is going outward is the weight, is due to the gravity. Next, we are going to talk about it still in the equilibrium, but I want to talk about the resultant force first. Resultant force is the summation of all forces which are acting to the object. To be considered equilibrium, it must obey below condition, which is the summation of the F for all of the axes must be equal to 0, and another condition is the summation of the moment of this must equal to 0. In equilibrium we have two, which is the equilibrium in 2D, and another one is equilibrium in 3D. For equilibrium in 2D, we must have about 4 types, which is collinear, concurrent, parallel, and general. So for collinear, it is straight. The line of action is straight, is linear, and the independent equation is the summation of fx is equal to 0. Meanwhile, for concurrent at a point, so this one is the free body diagram. It have two axes, so the summation of fx is equal to 0 and the summation of fy is equal to 0. Next, we have a parallel. For the parallel, the independent equation we have two, which is the summation of fx is equal to 0, and the summation of moment is also equal to 0. Next, and the last one is the general. For general, we have 3 types of independent equation, which is the fx summation of fx is equal to 0, summation of fy is equal to 0, and the summation of moment is equal to 0. Next, for the equilibrium equation, for equilibrium in 2D, it have three independent equations, which is the first one, like I said, fx equal to 0, fy equal to 0, or summation of moment is equal to 0. This one is quite general, but there is another one, which is the summation of x is equal to 0, and the moment of A is equal to 0, and the last one is the moment of B also must be equal to 0. Note that if we have three unknown, it is called a statically determinate. Meanwhile, if we have more than three unknown, it is stated to be called statically indeterminate. That's all for equilibrium in 2D. Next, we are going to move to the equilibrium in 3D. Equilibrium in 3D. So basically, equilibrium for this equilibrium in 3D, we have about 6 independent equations, which is the first one is fx is equal to 0, fy is equal to 0, fz equal to 0, and the moment at x direction is equal to 0, the moment at y direction is equal to 0, and the last one is the moment at z direction is equal to 0. So this for equilibrium in 3D, we also have 4 types, which is the concurrent at a point, concurrent with a line, parallel, and general. For concurrent at a point, the independent equation is fx is equal to 0, fy is equal to 0, and fz is equal to 0. Meanwhile, for concurrent with a line, we have about 5 independent equations, which is fx equal to 0, fy equal to 0, fz equal to 0. And the moment y is equal to 0 and the moment z is equal to 0. Meanwhile, for parallel, we have about 3 independent equations, which is fx equal to 0, and the two others is the moment, which is the moment of in y direction is equal to 0, and the moment in z direction is equal to 0. And the last one is the general one, which is usually we found this quite many. So the independent equation we have is 6, which is fx is equal to 0, fy is equal to 0, fz equal to 0. And for the moment is moment at x direction is equal to 0, moment at y direction is equal to 0, and moment at the z direction is also must equal to 0. So that's all for the equilibrium in 3D. So next we are going to talk about friction. Friction can be defined as the force resisting the relative motion of fluids layer, solid surfaces, and material elements sliding against each other. Friction can be classified into several categories, which is the fluid friction, internal friction, dry friction, and static friction. For the fluid friction, it is a friction between the layers of a viscous fluid in motion. Meanwhile, internal friction is the force resisting internal deformation of a solid material. And dry friction is the force that opposes one solid surface sliding across another solid surface. Meanwhile, the last is the static friction, which is the force that keeps an object at rest. So in this subject, we are focusing more to the dry friction than the others, which is mentioned in our reference book. So next, we are going to talk about the types of dry friction. There is 2 types of dry friction, which is the first one is the static friction. Static friction is applied when the object is stationary, and it is calculated using by this kind of formula, which is the friction force must be less than or equal to the coefficient of the static times with the normal force, and the unit for this is Newton, which is force unit. Then we have the second type of dry friction, which is the kinetic friction. In kinetic friction, it is a frictional resistive force that acts on an object that is in motion and in contact with the frictional surface. and this friction is calculated using the F is equal to coefficient of kinetics times by the normal force, and the unit also still the same, which is also Newton. So next we are going to analysis the type of dry friction problems that we have. Basically we have three types of dry friction problems, which is the first one is no apparent impending motion, and the second one is impending motion at all point of contact, and the third one is the impending motion at some point of contact. For the first case, which is no apparent impending motion, uh, it must obey the below condition, which is the force must be less or equal to the coefficient of static friction times with the normal force. And to solve this equation, we can use the equilibrium equation to solve it, which is the sum of force in the x direction is equal to sum of the force in the y direction is equal to sum of the moments is equal to 0. So right here we have one example, which is find the force of friction acting on the box if I push on it with a 10 pounds force. So basically we have the diagram right here, which the coefficient of static friction is 0.2. So right here we just use x direction because it is not, we don't use the y direction because it is only the forward, it is only involving the x direction. So basically we use the sum of the force on the x direction is equal to P minus F, which is the friction to the opposite the direction of the P, is equal to 0. Then we are going to get the force is equal to 10 pounds. Then we state it back into this formula to check whether it is correct or not. Then 10 pounds must be less than or equal to 0.2 times 500. So basically we got it correctly because 10 point is less than 20 pounds. So that's all for the case 1. Next, we are going to talk about impending motion at all points of contact. For this case, we must assume that a maximum friction is everywhere if the motion impending to object. Then the formula is the force static is equal to coefficient of static times with the normal. But if the body is sleeping, use Fk equal to coefficient of kinetics times with the Fn, which is the normal force. Next, to solve this kind of problems, we also need to use equilibrium equations to solve it, which is Fx equal to, which is summation of Fx equal to summation of Fy equal to summation of moment is equal to 0. So right here there is an example for this kind of problem, which is find the minimum force required to pull out the blue box. So right here we make two equilibrium equation, which is one at the x direction and another one at the y direction. So in this kind of problem we also have the force at the top, which is the 100 pounds box is equal to friction static of the top box times with the normal force of the top box. Meanwhile for the force friction for the bottom box, it is equal to coefficient of the static static coefficient for the bottom box times with the normal force for the bottom box. When we sub into this formula, then we will get P is equal to 0.05 times with 50 plus 0.15 times with 100. So we will get the answer is the minimum pressure is 22.5 pounds. The last problem for the dry friction problem is the impending motion at some point of contact. When we want to solve this kind of problem, we must assume that there is a sliding at one point. So we must use the formula that is F is equal to coefficient of friction times with the normal force. Then this kind of problem also can be motion or impending motion exists. Next, we also need to use the equilibrium equation to solve it, which is the same, which is the summation of fx equal to 0, summation of fy equal to 0, and summation of moment is equal to 0. Next, then after we got the answer, we must check back the answer by using this condition. The force that we got must obey this kind of condition at everyone else. So when it is obeyed, so we know that the answer is correct. So let we move to the example for this kind of problem. So for the example, find the question asks us to find the maximum force before the motion occurs. So for the first one, we make an assumption that a green box at the top is slips and the blue box remain. So at the green box, we will get the summation of fx is equal to P minus with the friction green box of the green box is equal to 0. Then we will get the P is equal to 15 pounds. Meanwhile, at the blue box, the equation that we got is the summation of fx is equal to fg with it with this, which is the friction of the green box minus by the friction of the blue box is equal to 0. Then we will get that the FB is equal to 50 pounds also, because from this equation we will get the FB is equal to FG. So from the upper calculation, we already got the FG is equal to P, which is 50 pounds. So this one also we will get the FB is equal to 50 pounds. So after we got it, we check the answer to know whether it is correct or not. Then when we check, we put the F is must be lower than or same with the coefficient of friction times with the normal force. Then the coefficient of friction is 0.05 times with the 150, which is the normal force. Then we got it is 7.5 pounds. So 15 is bigger than 7.5 pounds, so it is not obey. Then we can use the first assumption. We must do it again with assume slide occurs at the blue box surface with the floor. So next we need to make another assumption, which is the blue box slip and the green box stay. At the blue box, we will get the equilibrium equation if Fg minus Fb is equal to 0. Then Fg will equal to Fb. Then we will get the Fg is equal to 7.5 pounds. Meanwhile, at green box, we will get the summation of force at x axis is equal to P minus Fg equal to 0. Then P is equal to Fg. Then we will get the P value is 7.5 pounds. Then we already get the P value, but before that we need to check it with the previous condition, which is they must obey. which is this force must be less than the coefficient friction times with the normal force. So let's check it. So we put it into the formula. 7.5 is equal to a less than or equal to the mu times with the normal force. Then we will get that 7.5 is less than or equal to 15 lbs, which is this answer is correct. So next, I'm going to discuss with all of you guys about one random example of a friction. So the question asks us that the uniform crate shown in figure X7A has a mass of 20 kilograms. If a force P is equal to 80 Newton is applied to the crate, determine if it remains in equilibrium or not. And the information that they have given to us is the coefficient of static friction, which is mu s is 0.3. So before we begin, we must do the free body diagram first. So this is the free body diagram that we got from this picture. Then from this free body diagram, we know that the resultant normal force, which is mc, must act at a distance x from the crate center line in order to counteract the tipping effect that have been caused by P. So next, there are about three unknown, which is F, NC, and X, which can be determined straightly from the three equations of equilibriums. So when we already know the unknowns and all of that, we may begin the calculation. First of all, we use the sum of the force at the X axis is equal to 0. Then we know that the X axis only involve the F force, which is the friction, and the P force. So but this P force we must make it to the X and Y direction first. So from this P, we have got that 80 cos 30 degree, and it is positive because this this force is actually at this side. So when we solve it, it must be at this x axis and this for the y axis. So that why the x is positive, it is must be minus by the friction, which is to the left. So it's equal to 0. Then the next equation is the summation of force at the y axis is equal to 0. So we already know the P is negative when we solve it, this force. So it is why it is negative 80 times with the sine 30 degree. It is mass plus with this normal force because it is upward, so it is positive, and mass minus with this weight, which is downward, so it is negative. So equal to 0. Then the last equation, that is a moment equation. So for the moment equation, only P force and NC force involved in the moment. It is because in the P force, it is when we put P force at this crate, it can rotate. That's why this involved in the moment. And when the NC force, we make it to the crate, this crate also will rotate to this side. Meanwhile, this one, if we apply this force at the crate, it will not rotate. Same with the friction force. So that's why it only involves NC force and the P force. So from the moment, we know that P sine 30 times with the 0.4 meter and mass minus with 80 cos 30 times with 0.2, and it is mass plus with NC times with the X. Next, we are going to solve for this first equation, which is the summation of fx. Then we will get the F, which is 69.3 Newton, and from the equation summation of force at y axis, we will get the NC value, which is 236.2 Newton, and from the moment equation, we just subtract the F. We just subtract NC. No need to subtract the F. Just subtract NC in this equation, and then we will get the X value, which is the X we got negative 9.08 millimeter. So from this X value, we can conclude that when the X is negative, it is indicate that the resultant force acts slightly to the left of the crate center line. So no tipping will occur since X is less than 0.4 meter. Also, the maximum friction force that can develop at the surface of the contact of the crate is F is equal to coefficient of static friction times with the normal force. Then the maximum we got is 70.9 Newton, but the F we got here is 69.3, which is less than 70.9 Newton. So we can conclude that the crate will not slip and it will stay still, or it will stay in equilibrium. I think that's all from me for this video assignment, and I hope that you understand what I'm talking about, and thank you for your attention.